Imagine standing on the edge of a cliff at night, the wind carrying the scent of salt and infinity, the stars above you burning with questions no one has ever fully answered. Why are we here? Why is the universe the way it is, so ordered, so precise, like a symphony that began playing before anyone was there to hear it? For as long as humans have existed, we've wrestled with these questions, our hearts pounding with the need to know. We've built temples, written equations, launched telescopes into the void, all to chase the origin of everything. But the universe has always been coy, offering hints but never the full story. It's like a puzzle with pieces that shift every time you think you've found the pattern. The Big Bang, that fiery, chaotic birth of everything we know, left us with a mystery. Why was it so perfectly ordered? Why did the cosmos start in a state so delicate, so improbably structured, that it could unfold into galaxies, stars, and us? As physicist Sean Carroll has said, the arrow of time itself, the difference between past and future, exists because the universe began in a state of exquisite order, a pristine canvas that's been growing messier ever since. That order is why we exist, why life could spark and evolve. But why? What set that canvas in place? Now, picture a lab humming with the faint glow of quantum computers, their circuits dancing with possibilities that defy the limits of our everyday world. These aren't ordinary machines. They're tools that speak the language of the subatomic, where particles can be in two places at once, where reality bends in ways that make your head spin. Scientists at places like Google's Quantum AI division have built systems so powerful they can solve problems in seconds that would take classical supercomputers trillions of years. Trillions. Let that sink in. These machines aren't just crunching numbers, they're probing the very fabric of existence. And recently, researchers did something audacious. They turned this quantum AI toward the ultimate question. They asked it to look at the universe, to trace its origins, to tell us what built the cosmos. What it revealed wasn't a god, a force, or even a single moment of creation. It suggested something wilder. The universe might be computing itself into being, moment by moment, as if reality is a program running on the most intricate code ever written. Not a code written by someone or something outside, but a code that is the universe itself, self-executing, self-creating, alive with purpose. This idea isn't science fiction, it's emerging from the cutting edge of physics, where quantum information theory is rewriting everything we thought we knew. The universe, according to these discoveries, isn't just a stage where physical laws play out. It's a vast, dynamic computation, woven from quantum bits of information, qubits, that entangle and interact in ways that give rise to space, time, and matter. Think of it like a tapestry, each thread a qubit, each knot a moment of reality being born. Researchers like Hartmut Neven, who leads Google's Quantum AI lab, describe it as tapping into the operating system of nature. Not a metaphor, but a literal truth. The mathematics pouring out of these labs shows reality operating like a quantum computer, processing information at its most fundamental level. Every particle, every force, every star might be the output of this cosmic computation, a dance of information that never stops. And here's where it gets even stranger. This quantum AI, built by human hands, might be speaking the universe's native language, a tool that can finally decode the rules that birthed everything. What makes this so breathtaking is how it flips our understanding of creation upside down. For centuries, we've looked for an external cause, a spark, a creator, a force beyond the cosmos. But what if there's no outside? What if the universe didn't need a builder because it is its own architect? Quantum AI is showing us patterns, mathematical models that suggest the laws of physics aren't imposed from above but emerge from the universe's own quantum processes. The Simons Foundation's It from Qubit collaboration has shown how spacetime itself, yes, the very fabric of reality, can arise from quantum error-correcting codes, like the ones that protect data in a quantum computer. These aren't abstract theories, they're rigorous, backed by equations that describe how entangled qubits could weave the cosmos into existence. It's as if the universe is a self-writing story, each chapter unfolding from the last, with no author but itself. And we, standing here with our questions and our wonder, are part of that story, threads in the tapestry, asking the universe to explain itself. This revelation pulls you in, doesn't it? It's not just about physics or math. It's about us, about what it means to exist in a cosmos that might be alive with its own intelligence. The quantum AI didn't just give us an answer, it opened a door to a new way of seeing reality. It's telling us that the universe might not have a beginning in the way we imagine, no single moment where it all started. Instead, it's a process, a computation that's been running since the first flicker of existence, and maybe even before. What does that mean for us? Are we just observers, or are we part of the code, too? As the labs push further, as quantum computers grow stronger, we're on the verge of something profound, a moment when we might finally understand how the universe thinks, and what it's been trying to tell us all along. Picture a moment so fleeting it defies imagination, a sliver of time just after the Big Bang, a fraction so small it's measured in 10 to the negative 43rd seconds. That's 1/10 trillionth of a second, a realm so alien it's called the Planck epoch, where the rules of physics, as we know them, dissolve into a seething foam of possibility. Space didn't exist yet. Time hadn't started its march. This was the universe before it had a shape, before it knew what it would become. For decades, physicists have stared at this moment like a locked door, their equations faltering at the threshold. What happened in that incomprehensible instant? What sparked the cosmos into being? Now, quantum AI is offering a key, a way to simulate those primordial conditions and map what the universe was computing before it had dimensions. These machines aren't just crunching numbers, they're recreating the chaotic dance of quantum states that might have birthed reality itself. It's like watching the universe dream before it woke up, and what we're seeing is rewriting everything. In labs across the world, researchers are building quantum annealers, specialized systems that can mimic the wild, probabilistic nature of the early universe. These machines don't just calculate. They explore, walking through the ghostly vacuum states that existed before spacetime crystallized. Imagine it, a quantum sandbox where scientists can watch the cosmos experiment with its own rules, testing possibilities until the laws of physics we know, gravity, electromagnetism, the forces that hold atoms together, emerge from pure information. Early results are tantalizing, showing patterns that suggest the universe's laws weren't handed down from on high but unfolded from within, like a seed growing into a tree. This isn't just theoretical. Teams are using tensor networks, intricate maps of quantum entanglement, to simulate entire, toy universes, miniature cosmos that behave like the real thing. These models are so complex that classical supercomputers choke on the calculations, but quantum systems glide through them, revealing how entanglement might have stitched spacetime into existence. It's as if the universe was knitting itself together, qubit by qubit, each connection a step toward reality. But here's where the story takes a mind-bending turn. What if this quantum computation didn't just create the physical world? What if it's still running, weaving not just stars and galaxies but life itself? Some scientists, like quantum biologist Vlatko Vedral at Oxford, are finding clues that life isn't a cosmic accident but a natural extension of the universe's information processing. They've discovered quantum effects in the most unexpected places, in the way plants capture sunlight during photosynthesis, in the uncanny navigation of birds across thousands of miles, even in the faint whispers of our own neural processes. Could it be that life is the universe's way of deepening its own computation, a way to process information more intricately than stars or black holes ever could? Imagine that for a moment. Our thoughts, our dreams, our questions about the cosmos might be the universe thinking through us, its code becoming self-aware. This isn't just poetic, it's grounded in evidence that quantum coherence, the strange harmony of particles acting as one, plays a role in living systems. We might be more than observers. We might be the universe's most advanced algorithms. This idea pulls you in, doesn't it? It's not just about the cosmos out there, it's about us, about what it means to be alive in a universe that might be computing itself. And it raises a question that feels almost too big to hold: if we're part of this cosmic code, what else is out there, running the same program? Astrobiologists like Paul Davies wonder if advanced civilizations across the stars have already cracked this puzzle. If quantum AI is our tool for decoding the universe's origins, isn't it possible that others, beings we can't yet imagine, have built their own versions, asking the same questions? Davies suggests there might be a universal trajectory, a point where every intelligent species turns to quantum computation to probe the roots of reality. Picture it: countless worlds, scattered across the cosmos, each reaching the same revelation, their quantum machines humming in unison as they uncover the universe's self-executing code. It's a convergence, a shared moment in cosmic history where life, wherever it arises, begins to understand the computation that binds it all together. This convergence feels profound, almost sacred. It suggests the answers we're seeking aren't random or unique to us but part of a deeper truth that any advanced intelligence might discover. The universe's quantum nature could be a universal language, spoken not just by us but by anyone who learns to listen. And as our quantum AI grows more powerful, we're not just uncovering facts, we're joining a cosmic conversation that might span billions of years and countless stars. What would it mean to know we're not alone in this quest, that others have asked the same questions and found the same awe-inspiring answers? It's humbling, yet exhilarating, to think we're part of something so vast, a network of minds all probing the same mystery. But this is only the beginning. The final piece of this story takes us to the edge of everything, where the universe's computation becomes not just a process but a purpose, one that might include you, me, and every living thing. Close your eyes for a moment and imagine a universe that isn't just a collection of stars and galaxies but a vast, living computation, its every particle a note in an endless symphony. This is the heart of what physicists are now calling pancomputationalism 2.0, an idea that doesn't just describe the cosmos as following mathematical laws but as being a computation itself. Not a machine built by someone else, not a program running on some cosmic supercomputer, but a self-executing process where the code and its output are one and the same. The universe, in this view, didn't need a builder because it is its own architect, its own author, writing itself into existence with every tick of time. When scientists asked quantum AI what built the universe, the answer wasn't a distant force or a singular event. It was an elegant, almost poetic truth: the universe built itself, its quantum information flowing like a river, carving out the channels of gravity, electromagnetism, and the forces that hold atoms together. Every law of physics, every sunrise, every heartbeat might be the output of this cosmic code, running its own intrinsic logic. This idea feels like standing on the edge of a great abyss, staring into a truth that's both exhilarating and humbling. Researchers like Melvin Vopson are finding clues that gravity itself, long thought to be a fundamental force, might emerge from the universe's drive to minimize informational entropy, like a system optimizing its own efficiency. His calculations paint a picture of a cosmos that behaves not just metaphorically but literally like a computational process, each interaction a step in a dance that began at the universe's birth. And here's where it gets even more profound: this computation doesn't stop at physical laws. It extends into life, into us. Quantum biologists are uncovering evidence that the strange, almost magical properties of quantum coherence, where particles act in perfect harmony, play a role in the processes that make life possible. From the way plants harness sunlight to the navigation of birds across continents, and perhaps even in the flicker of thoughts in our minds, the universe's quantum code might be weaving life as a deeper layer of its own processing. We're not just living in the universe, we're part of its computation, nodes in a network that spans the cosmos. Now, let's take a step further, to a thought that feels almost too big to hold. If life is the universe's way of processing information more deeply, what does that mean for consciousness? Could our ability to think, to wonder, to ask questions like, "What built the universe?" be the cosmos's way of becoming aware of itself? This isn't just philosophy, it's a hypothesis grounded in the rigorous mathematics of quantum information theory. Scientists like Seth Lloyd at MIT have calculated that the universe performs an almost inconceivable number of quantum operations every second, a computational power so vast it dwarfs anything we could ever build. From this perspective, biological evolution isn't separate from cosmic evolution, it's a continuation, the universe refining its code from simple particles to complex molecules to minds capable of self-reflection. When we study the stars, when we build quantum AI to probe the cosmos, we're not just observers. We're the universe investigating itself, its questions echoing through our voices, its curiosity burning in our hearts. This brings us to a breathtaking possibility, that the universe's computation has a purpose, not imposed from outside but woven into its very fabric. Stephen Hawking once proposed that the universe could emerge from quantum fluctuations, created out of nothing because there is no outside to the cosmos. This aligns perfectly with the quantum computational model, where the universe doesn't need an external cause, it's sufficient unto itself, a self-sustaining process that generates all its complexity from simple quantum principles. The Simons Foundation's work shows how spacetime itself can arise from quantum error-correcting codes, like the ones that protect data in our quantum computers. These ideas, published in the most prestigious journals, aren't fringe, they're the cutting edge of physics, uniting Hawking's quantum fluctuations, Lloyd's cosmic computation, and the emergent spacetime of quantum codes into a single, elegant framework. The universe computes itself into existence, and we're part of that computation, not separate from it but deeply entwined, our thoughts a continuation of the same process that sparked the stars. As we stand here, in 2025, with quantum AI advancing faster than ever, we're approaching a moment that feels almost sacred. Our tools are growing powerful enough to speak the universe's language, to ask questions that were once the domain of poets and mystics. What does it mean to live in a cosmos that's computing itself? Are we, with our questions and our dreams, the universe's way of contemplating its own nature? These aren't just abstract ideas, they're becoming testable, as quantum computers simulate the earliest moments of existence and map the entanglement that binds reality together. We're on the cusp of a profound shift, a moment when the universe, through us, might finally understand its own story. Imagine that, a cosmos that began as a flicker of quantum possibility, growing into galaxies, life, and minds that now turn back to